Next we have exercise 9. So let's see what this one is. The photograph of a house occupies an area of 1.75 centimeters square on a 35 millimeter slide. The slide is projected onto a screen. Some distance away from the projector there is a screen and the slide is projected onto the screen so that you can see the image of the house on the screen. And the area of the house on the screen is 1.55 meters square. It will be large. The original slide is small, a 35 millimeter slide on which you have the image of the house, and the area of the house is 1.75 centimeters square there on the slide. But the projected house has this area 1.55 square meter. What is the linear magnification of the projector screen arrangement? So we can first calculate the aerial magnification, which is the area of the house on the screen divided by its area on the slide. Note that this, however, is given in meter square and this one is given in centimeter square. So we have to first of all change the unit. Say we turn this meter square into centimeter square. If you simply write centimeter in place of meter, what will you write along with that? 100, because 100 centimeters equal 1 meter. But there is square, so 10 to the power 4 centimeters square. But then after you cancel the units, this one will not have any unit. And this is what you get. This is the aerial magnification, from which then we have to find the linear magnification. And linear magnification is the square root of aerial magnification. That means the square root of this figure, which is this is an approximate answer. Okay, it comes out about 94.11, I think, but you can write 94.1. This projector and projecting some image onto a screen, this reminds me of a ghost story, in which what happens is that there is a projector and someone projects something onto the screen. It's the image of a door, and that screen becomes an actual door, and then it opens. Next we have number 10, in which some measurements are given. We have to calculate in each case the number of significant figures. So instead of writing a formal solution, let me just write the number of significant figures alongside these measurements. And let us recall what the rules were for determining that number in a given measurement. So what do you see here? In the first one, 0.007 meters square. It is area of something. You see 3 leading zeros, zeros that appear before all non-zero figures. Leading zeros are not significant, but any non-zero digit is significant. So here the number of significant figures is 1. So you have 1 here. Next, not number B, part B. This one is given in scientific notation. When you want to calculate the number of significant figures, you do not have to see the power of 10. You only see this part. This part has 3 digits and all 3 of them are non-zero, so they are significant. So that means here the number of significant figures is 3. Next, we have the density of something, because the unit is gram per cubic centimeter and the value is 0.2370. Okay. So here we have 3 significant figures which are they are significant because they are non-zero, 2, 3 and 7. But besides them, we also have this 0 and this 0. This is a leading zero, leading zeros are not significant, but this is a trailing zero. Trailing zeros are significant only if the number has a decimal point. Yes, this has a decimal point. So that means 3 plus 1. There are 4 significant figures here. What about this one? Same thing, sun, joule, okay, J stands for joule, some measurement. So besides these 3 non-zero digits which are significant figures, we have this trailing zero which is also significant because there is a decimal point. So here also there are 4 significant figures. Then this one, here the zero is neither a leading zero nor a trailing zero. It is a captive zero, a zero which is trapped between non-zero figures which are significant, 6 and 3. Captive zeros are always significant. So here also you have 1, 2, 3, 4 significant figures. Next, this one, again an area value. The 4 leading zeros are not significant. This other zero, which is a captive zero, is significant, and 6, 3 and 2 being non-zero are of course significant. So here also there are 4 significant figures. Next we have number 11. Here a rectangular sheet of metal is given whose length, breadth and thickness are given. Length is 4.234 meter, breadth is 1.005 meter and thickness is 2.01 centimeter, which is much smaller than length and breadth. You can understand, I mean, it's a thin piece of metal respectively. So we have to calculate the area and volume of this sheet of metal to correct significant figures. Not just simply we have to calculate mathematically the area and volume, but we have to keep in mind that the final answers should have the correct number of significant figures. So let's see how this can be done. So in the solution, we first write the things down that are given to us and we name them. We call the length L, which is 4.234 meter, breadth B, which is 1.005 meter, and thickness T, which is 2.01 centimeter, and we convert that into meter as well here, which you will get by dividing the centimeter value by 100. And when you do that, this is what you get, 0.0201 meter. Okay. Now first let us calculate area, and area does not simply mean length times breadth. Okay, be careful here. You are having a rectangular piece of sheet which has thickness. The thickness is not 0. So the area will be the total surface area. And you should take into account all the 6 faces. Each face is a rectangle, so accordingly you have the area formula. Taking into account all the 6 faces, this is your area. 2 times length times breadth plus breadth times thickness plus thickness times length. And now we will do the calculation. And we have to be very careful at every step. You will see why. So we first separately calculate LB. LB means L has this value and B has this value, meter times meter, meter squared. And then we do the ordinary multiplication and we get this value. But then immediately comes the number of significant figures here itself. What did we do here? We did multiplication, and when we do multiplication or division, we have to take that number of significant figures which is the least among all the measurements available. Here you have 2 measurements. How many significant figures are there in each one of them? Here there are 4 significant figures in the length value, because all 4 of them are non-zero digits. Here also there are 4 significant figures. 1 and 5 are significant because they are non-zero, and these two zeros are captive zeros. So they are also significant, and that is why your final answer should also have 4 significant figures. That's why you have to remove this 1 and 7. Because 1 is less than, the first insignificant digit is less than 5, so removal does not affect this preceding digit. It remains 5. You do not have to add 1. So that way you get 4.255 meters square. And then similarly we are going to now calculate BT and TL as well. You may be wondering why I am thinking of doing the significant figure thing here itself. That is because the rule for deciding the number of significant figures when you are doing multiplication or division is 1, whereas when addition is involved, it is something else. That is why. So the next product is the product of breadth and thickness. Breadth is 1.005 meter, thickness is 0.0201 meter. So that much meter square, their product. And that turns out to be this. Now how many significant figures do you see here? 4. Besides the non-zero 1 and 5, the 2 captive zeros are also significant. What about this one? The leading zeros, these 2 zeros are not significant. 2 and 1 of course are significant because they are non-zero, and this captive zero between them is significant. So there are 3 significant figures here. So that means the final answer should also have 3 significant figures. These 2 zeros again are leading zeros, so they are not significant, but 2, 0 and 2 are significant. So that way this is the value you should use. And finally comes the product of thickness and length, which is this times this, and the value is this. Here also this one has 3 significant figures that we saw just now, and this one has 4. So the final answer should have 3, although it's not really the final answer. Final means here. So these 2 zeros being leading zeros are not significant, but 8, 5 and 1 are 3 significant figures. And now we are going to use these products and consider their sum. And to decide how many significant figures the final sum value should have, another rule is followed. There we do not see number of significant figures, but we see which of the summands has the least number of digits after the decimal point. That's the different rule. So we next calculate the sum of LB, BT and TL, and the sum usually goes, and this is what you get, 4.3603 meters squared. Now here the rule for deciding how many significant figures you should have is different. Which among these 3 values has the least number of digits after the decimal point? This one, 3 digits, the others have more digits. So your final answer here in the sum should also have 3 digits after the decimal point, which means that you have to remove this 3, because 3 is less than 5, so it does not affect this preceding digit 0, and you get this figure 4.360 meters squared. Does it make sense to keep 0 here? Yes. Why? Because this 0 is a trailing 0 in a number which has decimal point. That is why it is significant. In a number which does not have decimal point, trailing zeros are not significant. So this is your sum value, but you still have to multiply by 2, and that also needs to be done carefully. So you next finally calculate the area value by multiplying this by 2. If you want, you can again write A equals 2 times that, but that's understood. Okay. Now after doing the calculation, here how many significant figures should be there? Recall that 2 is not a physical number. I mean, you haven't got 2 from any physical experiment in which you measured 2 using some device. 2 is a mathematical quantity. It's an absolute constant, and by uh, rule, by one of the rules, any such mathematical quantity, whether it is 2 or pi, something which does not come from experiment, is supposed to have infinitely many significant figures. And again you are doing multiplication. So the number of significant figures in your final answer should be equal to the number of significant figures which is the smaller among the two. This one has infinitely many, this one has how many? 1, 2, 3, 4. So your final answer should also have 4 significant figures, and the multiplication itself gives you just that. 8.720 meters squared is the area of the sheet, total surface area, correct to significant figures. The answer given in the book, however, unfortunately does not have this 0. I don't know why they keep doing these things. I mean, these are the rules. If they themselves do not follow the rules that they are teaching, then what are they doing? Next we calculate the volume. Volume calculation is simpler. You just multiply length, breadth and thickness, and this somewhat a big number you get. Big means having many digits, meter cube. And among these 3 given values, which one has the least number of significant figures? Thickness, that has only 3 significant figures. And again we are going back to significant figures, number of significant figures in the given values, because we are multiplying. So this also should have 3 significant figures. The 2 leading zeros are not significant, so after that you have to choose 8, 5 and 5. So this should be your final volume value.